Welcome to Get Your FRQ On. This question is from the Calculus AB exam, 2006 version B, question 3, and it's a calculator active question. This is the skateboard ramp question. And in the stem of the question, we are given 3 conditions that the ramp is supposed to satisfy. And in part A, we are asked to show that a function f of x equals ax squared cannot satisfy the second condition. So using the question stem, we're supposed to have the condition that f of 4 is equal to 1 and that f prime of 4 is also supposed to equal 1. However, if f of 4 is equal to 1, then a must be 1/16. If a is 1/16, this has certain implications for f prime. F prime of x would be 2 times 1/16 times x, which is 1/8 times x. And at 4, f prime of 4 would take the value 1/2, which is not equal to 1. And therefore, f of x equals a times x squared, no matter what a is, could not possibly satisfy the second condition. In part B, we are to find a value of c such that g of x satisfies the second condition. G of x is a cubic function of the form c times x cubed minus x squared over 16. So we're supposed to find a value of c such that the second condition is satisfied. And again, the second condition is that f of 4 is 1 and f prime of 4 is also 1. If we calculate g of 4 and set it equal to 1, doing the arithmetic, c times 4 cubed minus 4 squared over 16 equals 1, means that 64c minus 1 should equal 1. 64c would then have to equal 2, and then c would have to equal 2 over 64, which is 1 over 32. Okay, setting c equal to 1 over 32, and finding g prime of 4, and setting that equal to 1, we find that 3c times 4 squared minus 4/8 has to equal 1, which would imply that 48c minus a half equals 1, which would imply that 48c is equal to 3/2, which would imply that c is equal to 1 over 32 again. And therefore, if c takes the value 1 over 32, the cubic function g of x would satisfy condition 2. In part C, we are asked to show that the g of x in part B does not satisfy the third condition for the skateboard ramp. So we need to show that 1 over 32 times x cubed minus x squared over 16 does not satisfy condition 3, and we import the c equals 1 over 32 from part B. Again, we're working with the same function from part B, so we need to use the same values. To do this, we need to show that g of x is decreasing somewhere on the interval from 0 to 4. Condition 3 here requires that the path of the skateboard ramp is increasing on the entire interval. So if g of x is decreasing anywhere in this interval, it cannot satisfy condition 3. So we find g prime of x. We get 3 over 32 times x squared minus x over 8, which is x over 8 times 3/4 of x minus 1. This implies that g prime of x is equal to 0 when x is equal to 0, or when x is equal to 4/3. So on the interval from 0 to 4/3, 3/4 of x minus 1 is less than 0, which implies that g prime of x is less than 0, and therefore g of x would be decreasing on that interval. So if g prime of x is negative on the interval from 0 to 4/3, g of x is also decreasing on that interval. That's the first derivative test. And therefore, the g of x from part B cannot satisfy condition 3. In part D, we are asked to find a function that satisfies all 3 conditions. To do this, we showed that there's a function h of x of the form x to the n over k, which can satisfy all 3 conditions of the question. First, h of 4 equals 1. If h of 4 is going to equal 1, we would need 4 to the n over k to equal 1. This implies that 4 to the n is our value of k. If h prime of 4 is to equal 1, then we take the derivative of h, that would be n times 4 to the n minus 1 over k. That must also equal 1. However, since the first condition requires that k is equal to 4n, we can substitute 4n in 4k and simplify. N times 4 to the n minus 1 over 4 to the n simplifies to just n over 4. So n over 4 would have to equal 1, implying that n is equal to 4. If n is 4, going back to the previous line, n equals 4 implies that k is 4 to the 4th, which is 256. So now we have a possible h of x function, x to the 4th over 256. If we go with this h of x, x to the 4th over 256, h of 0 is 0, as required in the question stem. H of 4 is 1, as required in the question stem. H prime of x is the function x cubed over 64. If that is the case, h prime of 0 is 0, as is required in the question stem. H prime of 4 is equal to 1, as is required in the question stem. And h prime of x is positive for all x on the interval from 0 to 4, meaning that the h of x function that we've chosen is increasing everywhere on that interval. From this, we can conclude that the function h of x equals x to the 4th over 256 does in fact satisfy all 3 conditions for the ramp.